This video, we're going to be talking about partial fraction decomposition. It's the opposite idea of making a common denominator. So in this first problem, if I started off with x minus 12 over x minus 2 times x minus 4 in the denominator, I know that that comes from some numerator over x minus 2 plus some denominator over x minus 4. Now I'm going to go back and make the common denominator by multiplying here by x minus 4 over x minus 4, and here by x minus 2 over x minus 2. And this is going to be ax minus 4a plus bx minus 2b over x minus 2 times x minus 4. That gives me that a plus b, my x parts here, this x part and this x part together have to give me this x part over here. This is called comparing coefficients. And then I have another equation that's negative 4a minus 2b is equal to negative 12. This constant part and this constant part together have to give me this constant part. So I'm actually going to take the 2 out of everything that's in the second equation, because it's going to make my life easier. Negative 2a minus b equals negative 6. I have my equation set up for elimination already. If a is 5, 5 plus b is 1, b is going to be negative 4. So this is going to become a was over x minus 2. And then plus a negative is minus 4 over x minus 4. Why would we want to do this? It's very important in Calculus 2 to know how to do this. Sometimes in Calculus 1, this is one of the techniques where when you get to something called integration, especially when you're dealing with log rules, it's very useful in differential equations as well. So it's just one of those techniques for something later in mathematics. For right now, you're not going to see it a whole lot in pre-calculus, other than it's a pre-calculus technique that you're learning. So you're learning it in pre-calculus so that you can use it in calculus when you get there. 4x minus 17 over x plus 2 times x minus 3 is going to be a over x plus 2 plus b over x minus 3. These have all been distinct linear factors so far, and that is why I've been putting just a letter up there. If I want to multiply through by this common denominator, the equation that I get is 4x minus 17 is equal to a times x minus 3 plus b times x plus 2. And I'm going to show you a different technique, since this is distinct linear factors and lots of the teachers are going to do this. If I want to zero out this factor right here, I'm going to let x equal to 3. And when I do that, 12 minus 17 equals 0 plus b times 3 plus 2. So negative 5 is equal to 5b, and b is equal to negative 1. If I want to zero out this part over here with the b, I'm going to let x equal to negative 2, and that's negative 8 minus 17 equals a times negative 2 minus 3 plus 0. That's going to be a negative 25 equals a negative 5a. Divide by negative 5, and a equals 5. Those are exactly the same answers I would get if I used the comparing coefficients method. So a is going to be a positive 5 over x plus 2. B is going to be a negative 1, so that's going to be minus 1 over x minus 3. The reason that we learned about systems of equations and solving with matrices before coming to this topic was because we're going to sometimes want to solve the system of equations that we get with a matrix calculator because it's many variables and many equations, and we don't want to try and solve it by hand like I was just doing. So in this one, we're going to have 2x squared minus x minus 9 over x times x plus 1 times x minus 1 equals a over x plus b over x plus 1 plus c over x minus 1. So that means that 2x squared minus x minus 9 equals a times x plus 1 times x minus 1 plus bx times x minus 1 plus cx times x plus 1. So 2x squared minus x minus 9 equals a times x squared minus 1 plus b times x squared minus x plus c times x squared plus x. So 2x squared minus x minus 9 equals, again, I could have, and I should have, probably just let, I'm going to come back here and use my technique that I just showed you. Since I have distinct linear factors, I'm just going to let x equal to 0 to start off with so that b and c go away. And when that happens, I get negative 9 equals negative a, and a equals 9. Then I'm going to let x be equal to, and I want a and c to go away so I can solve for b. So I'm going to let x be negative 1. That's 2 times 1 plus 1 minus 9 equals 0. And that's a negative b minus 2 is a positive 2b. So this is 2 plus 1 is 3. 3 minus 9 is a negative 6 is 2b. And b is a negative 3. And then we have let x be equal to 1. If I do that, 2 times 1 is 2, minus 1 minus 9 equals 0, 0, 2c. Negative 8 equals 2c. C equals negative 4. So I get that this is 9 over x plus negative 3 over x plus 1 minus 4 over x minus 1. See if I get one more. I'm going to want to use the calculator here. Nothing yet because, number 6. I'll show you. I'll skip on down to that because that one's going to be different. So negative 4 x squared minus 14x minus 15 over x plus 2 times x plus 1 quantity squared. So see how this has a perfect square down here? That's going to make things different for me. I'm going to have an a over x plus 2 and a b over x plus 1. And then I'm going to have a c over x plus 1 squared. So I have to have every power of this from 1 up to this nth power represented with a letter over top of it. And we don't have any examples here of irreducible quadratics. So that's another option. But not here in these examples. So my common denominator is right here, and I'm going to have a times x plus 1 squared plus b times x plus 2 times x plus 1 plus c times x plus 2 needs to be equal to a negative 4x squared minus 14x minus 15. And because of this, it's not so easy to use the second technique. It's just easier to compare coefficients. And so for my x squared terms, I have a plus b. For my x terms, I have 2a plus 3b plus c. And for my constants, I have a plus 2b plus 2c. That equals negative 4x squared minus 14x minus 15. So that gives me a plus b equals negative 4. There's a plus 0c here. And there's 2a plus 3b plus c equals negative 14. And there's a plus 2b plus 2c is equal to a negative 15. So if we go ahead now and use our calculator, so 3 by 4 again, 1, 1, 0, negative 4, 2, 3, 1, negative 14, 1, 2, 2, negative 15. Second matrix, math, RREF, second matrix A, and we get an answer of A equals negative 3, B equals negative 1, C equals negative 5. So that's going to give us a negative 3 over x plus 2 minus 1 over x plus 1 minus 5 over x plus 1 squared. There's just some factoring that needs to be done in number 7 and number 5 before you get started. So this is going to be x minus 6 times x plus 1. This is going to be x times x squared minus 2x plus 1, which is x times x minus 1 quantity squared. So you're going to have a repeated root here, just like we had in number 6. You have a repeated root again in number 8. Let me talk about what happens if you have an irreducible quadratic as a factor in the bottom. For instance, if I had x cubed minus 1 down here, and I had, I don't know, let's just say x plus 2 up here. And this is going to be x minus 1. x squared plus x plus 1. This x squared plus x plus 1 doesn't have any more factors in the real world. It's only imaginary complex factors. So we're going to say that this is going to be a over x minus 1 plus, and then because this is quadratic, I'm going to go 1 degree less than that. Like so. So a times x squared plus x plus 1 plus bx plus c over x minus 1 would need to be x plus 2, something like that. I'm not even sure that this has an answer, but a x squared plus ax plus a plus bx squared plus bx minus bx plus cx minus c equals x plus 2. So for my x squareds, I have a plus b equals 0. For my x's, I have a minus b plus c equals 1. And for my constants, I have a minus c is equal to 2. So let's try that in my calculator. Let's just make a new matrix. 3 by 4, 1, 1, 0, 0, 1, negative 1, 1, 1, 1, 0, negative 1, 2. Second matrix. REF, second matrix number 2. And there we go. So my A here would be 1, my B here would be negative 1, and my C here would be negative 1. So the x plus 2 over x cubed minus 1 would be equal to 1 over x minus 1 plus a negative x minus 1 over x squared plus x plus 1. That's everything for this section, and this is the end of the college algebra material. I'll keep going with more pre-calculus videos that have to do with trigonometry if you are in a course that includes that as well. Keep checking the pre-calculus tag on my website. Also look for the trigonometry tag, but this is the end of the videos for the college algebra tag. All right, have a good day.